This is the Unit 5 review key video. If you follow this video, you'll find everything you need to know about this review sheet. Let's get started. First problem is use synthetic division to determine the quotient of that polynomial. So we're going to take our divisor, so x minus 1, set it equal to 0, get x equals positive 1. That's going to be the number in our little box. We bring the numbers from our polynomial down, so x to the third has a 1, negative 8, negative 3, positive 10. Now we just use synthetic division. Drop the first number, which gives us a 1. 1 times 1 is 1. Minus 8 is negative 7. Times 1 is negative 7. Minus 3 is going to be negative 10. Times 1 is going to be negative 10, which gives you 0. Now we had x to the third. We divided by an x, so now we have x squared minus 7x minus 10. That is our answer. Next question. We're going to use synthetic division, okay, in this graph to find our third factor. All right. We have two spots where we know the point on the graph where it crosses the x-axis. The first one is negative 1 comma 0. This one is 4 comma 0. We don't know what this one is right here, so we're going to find that one out. So question mark comma 0. There we go. So we're going to use these numbers, negative 1 and positive 4, to do synthetic division with the polynomial that we're given. So we have, it doesn't make a difference which one you start with. Use negative 1 first. We have 6, negative 28, 6, and 40. So we drop the first number to give us 6 times negative 1 is negative 6. Minus 28 is going to be negative 34. Times negative 1 is positive 34. Plus 6 is 40. Times negative 1 is negative 40. And that gives me 0. Now I'm going to use my other term that we're given, which is 4. I'm going to do this again. Drop the first number to give us 6. Times 4 is 24. Add it up, we get negative 10. Times 4 is negative 40, which gives us 0. So now we know our third factor is 6x minus, it's an x minus 10. And the other two factors, which are here and here, we have to put back as factors. They are currently solutions. So we're going to have x plus 1 and x minus 4. Notice the signs both change in those numbers because they are solutions, not factors. Now they are factors, so the signs will change back. And that is our answer. Same thing happens for the other question over here. We have another polynomial. We're given 3 different answers. We know this one is at negative 3 comma 0. This one is at positive 1 comma 0. And this one is I have no idea. Comma 0. So again, we're going to use these factors, or these solutions rather, to find our third factor that we don't know. So I'm going to start off with 1. Again, it doesn't make a difference which one you use. Negative 3 or 1 first is fine. Either one will work. You have to use both anyway. So you have negative 12 as your first term, negative 38, positive 8, and 42. Drop the first number to give us negative 12. Times 1 is negative 12. I'm going to add those two things together, which gives me negative 50. Times 1 is going to be negative 50. Plus 8 is negative 42. Times negative 1 is negative 42. And that gives me 0. All right, now I'm going to use my other term, which is negative 3, in the little box, and do the same thing. I'm going to drop the first number, which is negative 12, times negative 3 is positive 36. All right, that's going to give me negative 14, times negative 3 is going to be positive 42, gives me 0. So my factors are negative 12x minus 14, x plus 3, that's not 3, and x minus 1. Notice my solutions become factors, and I change the signs. And this is my answer. All right, it's synthetic division. So, starting with number 4, we're doing one of the new topics of this unit, which is solving rational functions. The first thing we have to do is stated right here, is find the domain restrictions. Okay, so we're going to take our factors from our denominators. We have p minus 2, set that equal to 0. We have p plus 2, set that equal to 0. And we have p minus 3, set that equal to 0. We don't need to do the other p minus 2 because it's already accounted for in the first one that we did. If we solve all of those, p will not be able to be equal to positive 2, negative 2, or positive 3. So these are our domain restrictions for this problem. If any of the answers we get out of this problem are either positive 2, negative 2, or positive 3, that answer won't work. Now we go to solving this. We've done the domain restrictions, now we got to solve. So what we're going to do is figure out what's missing. So the first fraction has p minus 2 and p plus 2 as its denominators. The second fraction is p minus 3 and p minus 2. What is missing from this denominator that the other side has? Well, it is missing a p minus 3. It doesn't have that on the left side. All right, in the denominators, we're going to multiply that on the top and the bottom. Now on the right side, we do the opposite. What does this have, or sorry, what is the other side missing that that side has? This has p minus 3, p minus 2. It is missing a p plus 2. The top and the bottom. Okay, now we can see that both our denominators share the same terms. They both have a p minus 3, they both have a p minus 2, they both have a p plus 2. Now that they are both the same, we can get rid of them. On the top, we're going to multiply. P times p, p squared. So we're just going to do the rainbow. P times negative 3 is negative 3. Negative 3 times p is negative 3p again. And negative 3 times negative 3 is positive 9. That equals, on the other side, rainbow that. P times p is p squared. P times 2 is 2p. 2 times p is 2p again. 2 times 2 is 4. Okay. So what we're going to do is I'm going to put all the p values to the left. So I'm going to subtract p squared and subtract 4p because 2 and 2 gives me 4. So minus p squared over here, minus 4p over there. All this stuff will go away. I'll be left with, on the left side, the p squareds will go away over there. Negative 3 minus 4 gives you negative 10p. I'm also going to take this 9 and subtract the 9 to the other side, which gives me negative 5. 4 minus 9 is negative 5. To solve for p, I next need to divide by negative 10, and p will equal 1 over 2. So 5 over 10 is 1/2. And the two negatives make a positive. So this is my answer. And since that answer is not 2, negative 2, or positive 3, that answer will work. Number 5. And number 5, unlike number 4, which was already factored for us, we have to factor these denominators. So we need to find two numbers that multiply to be negative 15 and add up to be positive 2. That will be positive 5 and negative 3. On the other side, we need to find two numbers that multiply to be negative 25 and add up to be 0. That would be negative 5 and positive 5. Okay, so now that we've factored our denominators, we can take those factors and make our domain restrictions. We have x plus 5 equals 0, x minus 3 equals 0, and x minus 5 equals 0. So when we solve all of those domain restrictions, we're going to get x cannot equal negative 5, positive 3, and positive 5. So if any of our answers that we come up for our solution equal one of those domain restrictions, we cannot use that answer because it would make our fraction undefined. Okay, so we've done our domain restrictions. Now we go on to solving the problem. Again, we have to figure out what's missing from our denominator. So the first denominator has x plus 5 and x minus 3. It is missing an x minus 5. We put it on the top and the bottom. The second denominator has x minus 5 and x plus 5. It is missing an x minus 3. Okay. Now both denominators have the three terms that are the same. Each one has an x minus 5, each one has an x plus 5, and each one has an x minus 3. Because of that, we can now get rid of our denominators entirely and focus on the top. We multiply. 3 times x minus 5 is 3x minus 15 equals 2 times x minus 3 is 2x minus 6. I'm going to subtract 2x from both sides and add 15 to both sides. So we'll get x on the left equals 9 on the right. So x equals 9. Since 9 is not negative 5, 3, or 5 as a domain restriction, that answer will work. Next question. Another rational equation. In this case, our denominators for this are n over 1, 17 over 1, and we just have n here. N is the only denominator we have, so we're going to set n equal to 0, and then say that that's what n cannot be. Okay. In this case, in our 3 fractions, n is the only term that's not in the other denominators. We're going to multiply this fraction by n and the 17 by n. Okay, so n just goes in the bottom as well. Now that all 3 denominators are the same, we can get rid of them. So n times n on the top is n squared. The 16 doesn't get multiplied by anything, and the 17 gets multiplied by n. Okay, now what we have is we're going to get a quadratic equation. We have to subtract the 17n to the left, so we get n squared minus 17n plus 16 equals 0. Now we need to find the factors of this. 2 numbers that multiply to be 16 and add up to be negative 17 would be negative 16 and negative 1. Negative 16 times negative 1 is positive 16, and negative 16 minus 1 is negative 17. We take both of those factors and set them equal to 0. You'll get n is equal to 16 and positive 1. Since none of those numbers is 0, from the domain restrictions, we're good. Number 7. Again, we have to factor these denominators. C squared minus 4 is a difference of 2 squares problem. Okay, 2 numbers that multiply to be negative 4 but add up to be 0 will be positive 2 and negative 2. That's the same for the last denominator as well. Okay, so now out of our 3 denominators, we have c plus 2 equals 0 and c minus 2 equals 0. Those are only 2 options that we have in our denominators. So c cannot equal 2 or negative 2. Okay. Now solving this, we should realize that the first and the last fractions have the same exact denominator. The middle one is missing a piece. It has a c plus 2. It is missing a c minus 2. Now that our denominators are all the same, we can cancel them out. The 1 on the top stays the same. Plus 1 times c minus 2 is c minus 2 equals 3. Okay. I'm going to subtract the 1 and add the 2 to the right-hand side. So that goes away, that goes away. I'm left with c is equal to 3 minus 1 is 2, plus 2 is 4. And there you go. Since 4 is not one of my domain restrictions, my answers will both work, or my answer will work. Okay. Moving on from this, we have transformations. All we're going to do is describe the transformations. Okay. So here at negative 5, since it's inside the function, it is a horizontal shift. And it moves, since it's negative, it's moving to the right by 5. The 8 is a vertical shift. It's making the graph go up by 8. Those are the only 2 things that are happening. Okay, next, there are 3 transformations in this. We're going to do this one first at positive 7. It's a horizontal shift. It's going to to go to the left by 7. The next one is the -4. It's a vertical shift. Going to go down by 4. Lastly, this is a 2. Since it's not in the function because it's not being multiplied by the x on the bottom of the denominator, this is a vertical stretch. By 2. And those are our 3 different transformations. Okay. So this is kind of the next step, which is to transform or to find some information about the graph and then also move the graph. Okay, so we have f of x equals 1 over x below. So this graph here, or this equation here, has not been changed at all. There's no transformations to it. And the graph that you see in this problem is for that equation. Now we're going to make some transformations of it. So I'm going to make these in red. So the +2 is going to be a horizontal shift, which moves your vertical asymptote to the left by 2. So we're going to move our vertical asymptote to the left by 2. And the -1 is a vertical shift, which moves our horizontal asymptote down by 1. So all we have to do then is redraw the graph with that new changed asymptotes. So we're going to have a graph be here, and be here. And that's it. That's all you got to do for the graph part. Now, part B, it says determine the y-intercept of k of x. So the y-intercept is where you're going to put 0 in for the x value to solve for y. So we're going to have 1 over 0 plus 2 minus 1. Okay, which gives you 1/2 minus 1. Okay, we can see that that's going to be, if you take the denominator of 2 and multiply it by this, on the top and the bottom, you get 1 over 2 minus 2 over 2. And now you can combine the two fractions. 1 minus 2 is -1 over 2, and this is your y-intercept. As a point. Oh, sorry, that was an x-intercept. I apologize. Put it in the wrong spot. It should be 0, -1/2 because it's a y-intercept. My apologies for that. All right. Question number 11. Same idea. We are graphing 1 over x. We want to regraph or change the graph based on its transformations. So we have a couple things going on here. We have the -3, which is a horizontal shift, which moves your vertical asymptote 3 spots to the right. So it'll be right here. The +2 is a vertical shift, which moves your horizontal asymptote 2 spots up. So your new graph will be here and here. Your domain and range are based on your vertical and horizontal asymptote. So I'm going to skip around a little bit. I'm going to write the vertical asymptote first. Our vertical asymptote was moved over 3 spots to the right, so that will be x equals 3. Your horizontal asymptote was moved 2 spots up, so it's going to be y equals 2. Your domain is based off your vertical asymptote, so that will be -∞ to 3. And jump over that, 3 to +∞. Your range, based on your horizontal asymptote, will be -∞ from the bottom to 2. We keep going up after 2 to +∞. Okay? Okay. This time the graph is shown below of 1 over x. It's the same kind of things that we've been doing the last couple of problems. I graph the function g of x by translating the function f of x up 3 and to the left by 4. So again, we're going to change our asymptotes. If it's going up by 3, our horizontal asymptote will go up by 3. Okay, and it's going to go left by 4. So our vertical asymptote will go to 4 to the spots to the left. Okay, so we're going to have to rewrite an equation after we graph this. So the graph will look like this. So because we were given points here and here, I moved those points up 3 and to the left by 4 to plot them again, to make it a little bit more accurate. Okay. Now, what is our new function? So we have g of x is equal to 1 over x. Now, because we moved to the left by 4, it's going to be plus 4 next to the x. Because we moved up by 3, it's going to be plus 3 on the outside. And this is our new equation. Okay, your domain is based off your, I'm going to skip around to this part too because I don't like the way this is ordered, but that's okay. Your vertical asymptote's based off of your horizontal shift. So now it's been moved to the left by 4, so it's x equals -4. Your horizontal asymptote's based on your vertical shift. So that's y equals +3 because the graph went up by 3. My domain is based off of my vertical asymptote. So I have -infinity to -4. And then -4 to +infinity. My range is based on my horizontal asymptote. So at the bottom I go -infinity to 3. And 3 to +infinity. My y-intercept, I'm going to put 0 in for the x value. So I have 1 over 0 plus 4 plus 3. So I have 1 over 4 plus 3 over 1. I multiply the top and the bottom of my second fraction by my denominator. I'll get it here and here. So I get 1 over 4 plus 12 over 4. When I have common denominators, I can now add the numerators. So I get 13 over 4. And I write that as my y-intercept as a point. 0, 13 over 4. And that's my answer. Again, we're doing a new graph based on some transformations. Okay. Our first part is -4. That's going to make our graph go to the right by 4, which means our vertical asymptote moves over by 4 spots. So here's my new vertical asymptote. The +2 means I'm going to move my my horizontal asymptote up by 2. Here's my new horizontal asymptote. I'm going to take my 2 of my points, this one and this one. I move them the same amount of distance I did for the asymptote. So I move it 4 to the right and up by 2, which puts it right here and right here. And I can graph those with my new graph. There we go. Okay, my transformations. Well, I only had 2. I've circled them in red in the equation above. And I told you what they were when we moved the vertical asymptotes and the horizontal asymptote. So, it is a horizontal shift to the right by 4 and a vertical shift up by 2. I'm going to do my asymptotes first. So my vertical asymptote is based on my horizontal shift. So x equals 4. Horizontal asymptote is based on my vertical shift. So y equals 2. My domain is based on my vertical asymptote. So -infinity to +4. And 4 to +infinity. My range is based on my horizontal asymptote. -infinity to 2. 2 to +infinity. My y-intercept, I have 1 over 0 minus 4 plus 2. Zoom in on this. So we have -1 over 4 plus 2 over 1. I'm going to multiply the 4 to the top and the bottom of my other fraction. So I get negative 1 over 4 plus 8 over 4. Now again, I haven't necessarily explained that, but 8 over 4 is the same thing as 2 over 1. It just looks different. But 8 divided by 4 is still 2. Now that my denominators are common, I can combine the numbers on the top. Negative 1 plus 8 is positive 7 over 4. Since this is a y-intercept, my y-intercept is 0, comma 7 over 4. And there we go. Next, use any method to solve the equation. So we're looking at the x values. So we have 3 x's, 1, 2, and 3. Each one of those that has the stuff has to be set equal to 0. So we have 4 divided by 3 times x squared equals 0. 2x plus 3 equals 0. X minus 5 equals 0. So for the first one, we're going to divide both sides by 4 over 3. You might be thinking, oh my gosh, 0 divided by a fraction, I have no idea. But 0 divided by any number is 0. So we have x squared equals 0. If we take the square root of both of those, x will still equal 0, because the square root of 0 is 0. That's our first answer. Our next answer, I subtract 3. On both sides, I still like 3. So I get 2x equals negative 3. And I divide both sides by 2 to get x equals negative 3 over 2. And the last one, I add 5 to both sides. So x equals 5. These are my 3 answers for this question. Next question. This is a solve by grouping because there are 4 terms. The first thing we have to do is subtract the 8x and the 12 to the left. So we get 2x to the third plus 3x squared minus 8x and minus 12 equals 0. Now that we have all the terms on the same side, we can group the first 2 and the last 2. Out of the first 2 terms, 2 and 3 don't have a common number to take out, but x cubed and x squared do, and you can take out an x squared. We're left with 2x plus 3. And the next problem, for negative 8 and negative 12, we can take out a negative 4, which will leave us with 2x plus 3. This is a good thing because these 2 sets of parentheses should be exactly the same. If you only take a positive 4 out, you'll be left with negative 2x minus 3, and then those 2 parentheses won't look the same because you've done something wrong. Now we can put our factors together. So we have x squared minus 4 as our first factor, and 2x plus 3 as our second. But wait, there's more. Because this first factor is a difference of 2 squares as being x squared minus 4, you can factor that some more. 2 numbers that multiply to be negative 4 and add to be positive 0, or negative 0, just added to be 0, are positive 2 and negative 2. And we still have the 2x plus 3 left over as well. So these are the 3 factors that make up that polynomial. Next. This is a problem where we have a greatest common factor. You have 2 and negative 32, you can take a 2 out. And you have x cubed and x, you can take an x out. What's left over is x squared minus 16 equals 0. Now the 2x is done. I'm going to put that down here and set it equal to 0. But the x squared minus 16 is just like the problem we just had up here. It's like the x squared minus 4. This is a difference of 2 squares. So 2 numbers that multiply to be negative 16 but add up to be 0 would be negative 4 and positive 4. Not negative and positive 8. That doesn't give you 16. That only gives you 64. So we take those factors, x minus 4, set it equal to 0, and x plus 4, set it equal to 0. When I solve all these, my x will equal 0, positive 4, negative 4. And now I'm done. Last one of these solvings. So we have to add 3x cubed to the left. Now there's a really important reason why I want to do that, and that is I want my first term in my polynomial to be positive. If I left it on the right, it would be negative, and that's not as much fun to factor. Now these might seem like big numbers, and they are, but we can take a greatest common factor out. Every one of these numbers, 3, 27, and 60, can be divided by 3. All right. All the terms can also be divided by one single x. We're going to take an x out as well. What's left over is x squared minus 9x plus 20. Now I can factor this quadratic here. So two numbers that multiply to be 20 but add up to be negative 9 are going to be negative 5 and negative 4. Negative 5 times negative 4 is positive 20. Negative 5 minus 4 is negative 9. I still have that 3x there, so I'm going to take my three factors, the 3x, the x minus 5, and the x minus 4, and set them all equal to 0. If I solve all of them for x, I will get 0, 5, and 4. Moving on, we have some work problems. Working alone, Adam can harvest a field in 16 hours. So we're dealing with Adam. Again, as I've said before, please label these things so you can organize your information and they're easier to solve. We have Dan. And we have them working together. They're working in a field over time. So Adam can harvest one field in 16 hours. Dan can do the same field in 13 hours. And together, if they did one field, how long would it take them? Okay. So this problem, we have to multiply by what's missing on the bottom. So the first fraction is 16. It's missing 13 in x. The second fraction is missing 16 in x. The last fraction is missing 16 times 13. So for this, we're going to need a calculator. I'm going to do this one just because I want to. That's all I need. All right. So now that all the terms... Here, let's put this... Oh, I knew it. I knew it. I knew it. I lost my pen. Let's go back down to the bottom here. Sorry about that. I'm missing the 13x on the bottom, the 16x here, and the 16 times 13. Now that all the terms have 16, 13, and x, I can get rid of those bottoms and multiply the top. So 13x times 1 is 13x. Plus 16x times 1 is 16x. And 16 times 13 is 208. I combine 13 and 16 to give me 29x equals 208. And divide both sides by 29. So x will equal 7.17 hours. That's it. Next. Leah can clean an attic in 10 hours. So we have A for her. Stefan can clean the same attic in 15 hours. So we're doing clean over time. You can do 1 in 10. Stefan can do 1 in 15. Together, how long would it take them? Okay, now, there's a couple ways to do this problem in a sense, because 10 and 15 share a common term before 150. They share 30. So 3 times 10 is 30, and 2 times 15 is 30. I think just to be easy, we're just going to multiply what's missing and not be a little bit fancy. So this is missing 15 in x. This is missing 10x. This is missing 10 times 15. So this is 15x, 10x, 10 times 15. So now they all have a 10, a 15, and an x. We can get rid of the denominators. We get 15x plus 10x equals 150. This is 25x equals 150. Divide by 25 on both sides. And that gives you x equals 6. How many hours? Oh, hours. All right. Next, Allie can make 2 hot cocoa bombs in 5 minutes. We have Allie. We're making cocoa. There you go. Over minutes. We'll just do time. I don't like how you spelled cocoa either. Cocoa. There we go. Time. You can make 2 in 5 minutes. Cardia can make 4 in 9 minutes. Ellie works by herself for 25 minutes. Is joined by Cardia. How long will it take them working together to make a total of 144? So that's a little bit tricky. We haven't necessarily seen this type, but if you think about it, we're talking about Allie working for 25 minutes by herself before the other one joins in. Well, she works for 5 minutes, she gets 2 done. So what times 5 gives you 25 minutes? That's 5. So if she can make 2 in 5 minutes, in 25 minutes, she can make 10. So what we're going to do is we're going to take 10 off of the total. Okay? So it gives you 134. Oh, sorry, put it in the wrong place. 134. We're looking for her time, their time. So again, if she works for 25 minutes, and every 5 minutes she makes 2, she makes 10 by herself before the other girl joins in, or other person. Okay, so we take 10 off of the total of that they had to do together. So that's why it's 134. Okay, now we go to the same process we've been doing. The first one's missing 9 and x. Second one's missing 5 and x. Last one's missing 5 times 9. Now that every denominator has 5x and 9, we can get rid of that. So 9x times 2 is 18x. 4 times 5x is 20x. And 134 times 5 times 9 is 6,030. Okay. So 18 plus 20 is 38x. 60, 30 divided by 38. And x will equal 158.68 minutes if they're working together. We got Mario needs twice the time Nikki needs to build a snow fort. So Mario, Nikki, we have them together. If they work together, it takes 45 minutes. Oops, I made a mistake. Forgot the numerator. We're building one snow fort together in 45 minutes. Okay. How long would it take Mario to build a snow fort working alone? So Mario needs twice the time as Nikki does. So if Nikki's time is x, because we don't know what it is, it doesn't say it, Mario's time is twice as much as Nikki's, so we put 2x. Okay. So now we solve. Okay, this one's a little more complicated again. All right. Again, the tricky part is understanding that you're not given the times for Nikki or Mario, but Mario is twice the time that Nikki needs. So if we don't know Nikki's, we put an x. If Mario is twice as long as Nikki's, it's 2x. So we are missing a 45 over here. We're missing a 2 and a 45. I'm missing a 2 and an x over here. So now every denominator has 2x and 45. So we can get rid of these. So we have 45 on the top plus 2 times 45 is 90 equals 2 times x is 2x times 1 is 2x. So 90 plus 45, 135. Divide both sides by x. Or sorry, by 2. X is equal to 67.5. Now, here's the tricky part about this one also. It doesn't ask us how long does it take Nikki to make a fort. It asks how long would it take Mario working alone to build a snow fort. Well, this part of our equation right here is Mario. So it takes Mario takes 135 minutes. Okay. So in this case, you don't really need to solve for x because we're looking for Mario's time. Nikki's time is 67.5, which means Mario is twice as long at 135. All right, next. Chance the rapper wants to invest his money into a stylist business. He charges a one-time setup fee of $30 per order and then a $1.50 per stylist. Determine the total cost if 50 stylists are sold, and what is the average cost per stylist. We talked about these types of problems. There's two questions, the total cost and the average cost. So we're doing 1.5 times 50 stylists plus the $30 setup fee. Yep. So we do 1.5 times 50 plus 30, which gives us 105. Now the average is taking the total, 105, and dividing it by how many stylists were sold, so 50. The average is 2.1. That's still an ugly dollar sign. Let's try that again. There we go. So $202.10 for the average, $105 for the total. Okay. Now we're going to write an equation to represent the total cost. Okay, which we're going to use the equation from right above it. So we have the total cost, C of x, is equal to 1.5 times the number of styluses, in this case is x, plus 30. That's it. Part C, the average cost is based on the equation right above, but the total cost is still included. So we're going to do the average cost, so A of x equals 1.5 times x plus 30 divided by x. All right. If a customer has 150 to buy stylists, how many stylists could they buy? So we're looking for the total cost. So this is the total cost. We're going to put that on the answer or the end of our total cost equation. So $150, 1.5x plus 30, and now solve for x. Subtract by 30 on both sides. So $120 equals 1.5x. Divide by 1.5 on both sides. And 120 divided by 1.5 is 80. Styluses. All right. Last, if a customer wants the average price per stylist to be $1.80, how many styluses should the customer order? So we're going to put the 180, kind of like we did last problem, in for the A of x. So we got 1.8 equals 1.5x plus 30 divided by x. Well, 1.8 has a denominator of 1, so this side is missing an x. Now both sides have an x in them. We have 1.8x equals 1.5x plus 30. Now we subtract 1.5. So 1.8 minus 1.5 is 0.3. I'll just show you. So 0.3x equals 30 divided by 0.3, and x will equal 100. There you go. Last question. Miss Marlega is planning her wedding reception at a banquet hall. The hall has a fixed charge of $300 plus $35 per person for food. Determine the total cost of the banquet and the average cost per person. So again, we're looking for two things, the total and the average cost. So it's $35 for 95 people plus the $300 fixed charge. So 35 times 95 plus 300 equals $3,620. That's the number, $25. Now Now the average cost is that total divided by how many people are coming, which is 38.16. Here are our two answers. Okay, like before, we're going to represent the equation for total cost with C of x is equal to the $35 per person, in this case x, plus 300. The average cost is A of x, which is the total cost, 35 times x plus 300, divided by the total number of people, which is x. And then lastly, if my Mar-a-Lago wants average price per person to be $37.50, how many people should attend the wedding reception? So you're going to take that number and put it in for A of x. So it's going to be 37.5 equals 35 times x plus 300 divided by x. The left side is missing an x. And now since they both have x's, we can get rid of that. If 37.5x equals 35x plus 300, subtract 35x from both sides. 37.5 minus 35 is 2.5. Divide that by 2.5, and 300 divided by 2.5 is 120. And that is the end of the review. Please take some time to do the review and any practices you have not done to practice for the test. Good luck.